students. Today we are going to perform our first experiment in process dynamics and control lab, that is time constant of manometer. So here you are going to operate a YouTube manometer equipment and you will find out the characteristics of the manometer. So before we will get into the experimentation part, we will know little bit theory about the manometers. So what is a manometer? Manometer is a pressure measurement device. By using this we can find out the pressure. And how we will find out the pressure? We can find out the pressure of the pressure you can measure by using by balancing the liquid height. Okay, and in that case the liquid will be in static equilibrium. Fine. So before we get into the experiment, as I told you, first we will see the different types of manometers. First look into this particular picture. So this is a simple manometer where we will use a liquid and we have one vessel and which is connected to the vertical column. Okay. So inside this vessel we have a liquid which has a density of A. Fine. This liquid is A. We will consider the liquid is A. So now the height of the liquid, whatever it is there, it will be measured, like it will be controlled with the atmosphere pressure that I have denoted with the P atmosphere. So to find out, if you want to find out the pressure of a liquid A, how we can find out? Pressure P A that equal to this particular liquid, whatever the liquid is there, that liquid density, that is rho, and the gravitational force G and height of the liquid. What is the height of the liquid here is when we are applying some pressure on it, the height of the liquid which is raised, the height of the liquid which is raised. So it is raised up to H. So that is the height of the liquid. So this is the simplest equation to find out the density of a given, the pressure of a given liquid. Similarly, you can see the second type of a manometer, that is YouTube manometer. You can see those two diagrams. So the first one is the type 1 diagram and type 2, the type 1 equipment and type 2 equipment. The type 1 equipment is the gauge pressure. Gauge pressure. What do you mean by gauge pressure? The gauge pressure. You are going to find out the gauge pressure here. So that means the pressure of a liquid over here. Okay. So in this case, we are using two type of liquids. One is the heavier liquid. Second one is the lighter liquid. So the left side you have a lighter liquid and the right side you have a heavier liquid. Most of the cases, the lighter liquid we will take it as water, H2O. And the heavier liquid case we will consider heavier liquid we can mostly consider the mercury. Okay. So in this case, the left side case, I am taking the liquid as water and the density of the liquid I am considering it as ρ1. Okay. And for the case of heavier liquid I am considering the density of the liquid as ρ2. For your better understanding I am writing here. Okay. ρ2. Okay. And the liquid height from here to here, the liquid height B liquid, that means liquid 1 height is H1 and liquid height H2. And the liquid height is from, the second liquid is from here to here, but when it comes to the calculation part, we will have a reference line. We will have a reference line that we will call it as a datum. So below the datum, we will not consider the values. Below the datum, we will not consider the values. We only consider the values above the datum line, that we can call it as a reference line. So now let us see how we can find out the density, the pressure of both the liquids. Okay, how we can find out the pressure in the particular equipment. So first one, the left side. That is, what is the left side? Pressure here. The left side you have T1 I have write down simply for your like P left. So let us write down P left equal to, first one, the liquid pressure, that is PB, plus the density of the liquid rho 1, and the height of the liquid H1 and gravitational force G, rho 1 G H1. And again we will write down the right side pressure, so P right. P right. So here we have a liquid 2 which has a density of, as I told you, density of rho 2 into gravitational force G into the height of the liquid H2. Now what I will do? P left equal to P right. So PB plus, first I am writing down the P left. PB plus rho 1 G H1, that equal to rho 2 G H2. So I will simply take this term into the right side. So I will get PB equal to, that is what I have to find out, right? The liquid pressure, the gauge pressure of the liquid B. So the PB equal to rho 2 G H2, and I am taking this term into the right side, so it will be negative rho 1 G H1. So this is the equation to find out the liquid pressure in the vessel. The second one is the type 2 that we will call as a vacuum pressure. What is the vacuum pressure here? The one side of the manometer will be connected to the vacuum system, where we will give a continuous vacuum to the system. So here what happens? The pressure here, the vessel B will be less. The pressure in the vessel will be less as compared to the liquid which is there in the gauge pressure. In the gauge pressure, the left side liquid, the B liquid pressure will be more, and in a vacuum pressure manometer, the pressure will be less. And this side, since we are giving the vacuum, where we have connected to the vacuum, where the vacuum is very high, like the pressure is very high here. So since we are giving a high pressure this side, so what happens? Whatever liquid it is there, that will be transferred to this side. So we will note it down, both the liquids, the heavier liquid and lower liquid height here. And below the, as I told you in this section, we will not consider below the datum line, we will not consider for the calculations. So if you want to write down, if you want to find out the pressure here, how we can find out? The P left equal to what you have? One is the B, PB plus, first we are writing for the lighter liquid, that is rho 1 G H1 plus the second liquid height is also in the left side only. So rho 2 G H2. Okay, since the pressure in the right side is very high, therefore there is no height above the deck, because due to the high pressure, the liquid will be completely goes to the left side only. So if you want to write down P right pressure, here what happens? There is no liquid. There is no liquid means there is no pressure. It is 0. So if you write down P left equal to P right, what you will get? PB equal to you will get minus rho 1 G H1 plus rho 2 G H2. If you observe properly, since you have the pressure in the left side, in the vessel, the pressure of the liquid in the vessel is less, so you are getting a negative pressure here. You are getting a negative pressure here. So like this, you can compare both U-tube manometer types. One is the gauge pressure and the vacuum pressure. I hope it is clear. And we have a next type, that is a third type. Like the simple manometer and U-tube manometer, we have a third type of manometer, that is differential manometer. Okay. Now we are going to see the third type of manometer, that is differential manometer. As you can see, now we are connecting the manometer to two vessels. The vessel 1 which has a liquid A and vessel 2 which has a liquid B. So now I am taking the liquid A density is rho 1 and liquid B density is rho 2. And the height of the manometer, the height of the liquid in the left side is X plus H. Here it has three liquids. I forgot to tell you. One is liquid A and liquid B. Mostly these liquid A and liquid B are lighter liquids, and liquid which has below the, which is I have denoted here in this range. The liquid which I have denoted in this range, that is a heavier liquid. Most of the cases that is mercury, and which has density of rho H. Now what I will do? I am going to find out the pressure of a liquid A and pressure of a liquid B. In differential manometer, you will calculate either difference between liquid A, pressure in the liquid A minus pressure of liquid B, or you can find out PB minus PA. And another thing, this A and B liquids, in most of the cases, liquid A and liquid B are same. Okay. So now let us see how you can find out either PA minus PB or PB minus PA as per the diagram which I have shown. So earlier, as we have calculated earlier, P left and P right we will write down. Right? P left. What is the P left? The pressure of the liquid in the left side, that is PA, plus the density of the liquid, that is rho 1. As I told you, I have mentioned here rho 1, and gravitational force in the left side, that is G, and height of the liquid. Height of the liquid in the left side, here to here and here to here. So here to here the height is X, and here to here the height is H. That is X plus H. Here. Now the right side liquid. Right side liquid is, I have two liquids. As I told you, here I have a heavier liquid, that is mercury, and here I have a liquid B. So first of all, liquid pressure PB, the right side liquid is B, so PB plus, up to here we are taking first. Up to here the liquid we are taking. Rho 2, the liquid is rho 2, the PB liquid rho 2. Gravitational force and height of the liquid is Y. And the third liquid from here to here I am going to take now, that is a mercury. That is density of the mercury rho G, and height of the gravitational force G, and height of the liquid is here, that is H. Now what we will do? P left equal to P right. You can write down this PA plus rho 1 G X plus H. Okay, and that equal to P left equal to P right, that is PB plus rho 2 GY plus rho Hg instead of the mercury into G into H. Now as I told you, either we can find out PA minus PP or PP minus PP. I am going to find out PA minus PP here. That means I will take the PP term this side, and I will take this whole term to the right side. PA minus PB, that equal to, this term first I will write now, rho 2 GY plus rho Hg and to G into H, G into H, minus, because this term is plus in the left side, and you are taking this term into the right side, it will become negative, minus rho 1 G X plus H. Okay, X plus H. You can simplify it more. Rho 2 GY plus rho Hg and GH minus, I am multiplying this term with X and H, minus rho 1G X minus rho 1G H. Here you can see GH and GH are common. So I will take the GH common in this term. So I will get it simplified. Final equation is rho 2 GY minus rho 1 GX. Okay, rho 1 GX minus, or you can take plus I am taking GH common here. GH I am taking common. So plus rho Hg minus rho. That is Pa minus Pb. So like this, you can find out the pressure in the differential manometer. You can find out either from here you can find out Pb minus Pa also. Means you can take this Pa term into the right side and this whole term into the left side. Then you can find out Pb minus Pa. Okay. This is how you can calculate the pressure in simple manometer, gauge pressure manometer, or vacuum pressure manometer, or in the differential manometer. So I hope the theory portion is clear to all. I have given very little bit theory about the measurement manometers. So now we will get into the experiment.